Hey, Code and How It Works class. So this video is going to be a little bit different. This is about a problem that I'm having. This is why we sort of stalled out on making those circuits where we were going to make and, or, and not gates for you guys, and we're going to use the transistor. Inside this transistor is a semiconductor, and it's how the semiconductor works physically is described in the um, Veritasium video that is on our haiku page. And we should be able, just with a little bit of semiconductor and 3 leads to that semiconductor, we should be able to assemble all of the and, or, and not gates that we need in order to make a computer. However, I've been having the worst time with this simulation. And if any of you guys have a parent who's an engineer who wants to debug it, I would love it. Or if any of you guys debug it, I would love it. The replacement is going to be, I'm going to do another video about how to use integrated circuits. And my concern with that is that an integrated circuit, we look at integrated circuit, and thank you again to Jeevan who found this. Oh, I have to go to all components. Let's see if it'll come up. Might come up under integrated circuit. Okay, so an integrated circuit is a little block that has a lot of circuits inside of it. Okay, so it's way down here. Down here in the logic. So these guys, and our first one that we're going to use is going to be an OR gate. This inside here are multiple OR circuits that you can use. My concern with using those with you guys is it doesn't look as clear that it's just a little transistor that's doing this. It's kind of like this mystery black box. And our whole purpose is to make the mystery black box of the computer go away so you understand what's going on. So I'm a little concerned about that, but let me show you what the problem is. So in the previous video, when I was showing you how the transistor works, and you have to watch that one first, the transistor is a switch. And when I start the simulation, the switch doesn't have any power going to the base. By sending power to the base, I change the material inside of it. I charge it up as we see in the Veritasium video, and it will turn this on. So without power going to the base pin, this is a switch that is off. So the circuit is broken. But as soon as I send power to the base, it lights up. Now, what should work for a gate is this. If I add another transistor, and I want to make an AND gate, I'm going to add another battery just because I want to make it clear where the power is coming from. Okay, so now I have 2 switches in a row. Now, if these were light switches, you would know that they both have to be turned. If I have a switch that's coming and I have a connector that comes from here to here, and then it comes from here to here, and both of these are switches, then it would make sense to you that to complete these circuits, they both have to be in the on position because the electricity has to go through here. And then if this is broken, then it won't go. And if this one is on and this one is off, well, it can't even get that far. So if we provide power to the base, connect the grounds all together, okay, so this should work, and it does, which is great. So, so both switches, I've put power to both switches, and the it does in fact go on. Just gonna rotate this and see if that's a little bit more clear. Maybe it's less clear that way. Um, all right, so we'll just leave it back that way. Okay, so our signal, our 0 and 1, are coming in. Let me color those differently. I'll color them blue because blue is often the color of information. Doesn't change at all, the color doesn't change at all what's going through there. So our signal, our 0 and our 1, are coming through here. And so when both of these are connected to power, they are both 1, and our output, when this is on, should be, it counts as a 1. So this and that, so 1 is true. So if this is true or 1, and if this is true or 1, then this should be true or 1, which also counts as on. Okay, so my problem that I get is when I start testing this. So let's delete this one. And now this should be broken, but it isn't. And this is where I get the problem. I don't see any way that electricity should be flowing in this circuit. What should happen is when I remove that, this should be in the open position and this should not light up, but it does. So we're not going to be able to use these transistors unless maybe one of your parents is a my engineer, I have a background in engineering, but I did not have to do electrical circuits past freshman physics in order to get my degree. So I never did much work on it except when I'm messing around with Arduino and stuff. So maybe one of your parents who's an electrical engineer or any other sort of engineer could tell me what I'm doing wrong, something simple. My husband hasn't found it either, and he's much better at electrical engineering than I am. So, that's not a sexist thing. I do the math when he needs calculus or differential equations, or he does statistics, but I do the differential equations and calculus in our relationships. Not, it's just he he liked it better. He knows more about it. So that's why we're not doing the plain bare transistors. If anybody knows a solution to the problem, let me know. Otherwise, I'll try to submit it as a bug, but there's probably no way they'll get back to us in time if it is a bug from Tinkercad. All right, thanks. Bye.